Okay, let's review our log rules to make sure you know all of them, and then we're going to do some practice. The first rule, log base A, any base when the of is a 1. That rule says it's going to equal 0. What if it's log base A of A? That answer is going to be 1. You could do a log circle to check to see if that's right. What if the base is A and the of is A? What does this rule say? Then you get the power R. What if the base is A and then the power has a log and that base is A and the bases are both A? Then you just get M. Okay, these are very popular rules here for when you're solving. If you have a log and the ofs are being multiplied, you can separate this into two logs. What are the bases for both of them going to be? That's right, A, log base A, log base A. And you're going to take the ofs and you're going to separate them. This is going to be log base A of M, log base A of N, and what do you do to the two of them? You're going to add them. If the ofs are being divided, you can go ahead and separate log base A of M. That one goes on top, that one goes first. And then you're going to subtract log base A of N. If you have log base A of M to a power, that power can go where? Bring it down in front. The base and the of are different, so we can only bring that down, make our coefficient R times log base A of an M. And rule number 8, if a log equals to a log and the base is equal to the base, then you can say that the of on the left equals the of on the right. Okay, and so you're just isolating the ofs. You're not dividing by log or anything. You're just saying that the ofs must be equal. All right, we're going to use these rules to do some solving and practice and get good at this. The first thing I notice here is I have two logs. So I'm thinking about using rule number 8, where a log equals a log, except there's a 2 there. So I can't isolate the ofs. These are not log equal log because there's a 2. Where can I put that 2? If I divide by it, then I'm making a fraction over here, and that's not getting any better. But if I use rule number 7 here, I can take that coefficient and put it up as a power. So let's go ahead and do that. Log base 5, and I'll bring it up here, and now it's x squared. It becomes a power on the of. If you want to use parentheses, you can do that. It belongs to x. Equals log base 5 of a 9. Okay, now I have a log equaling a log. When you have two logs that are equal, you don't do a log circle. Okay, if you have two logs that are equal and the bases are equal, then you're going to isolate the ofs. So what we'll do here is we're going to say x squared equals 9. And I'm going to go ahead and square root it. And so my answer is plus and minus 3. X is plus and minus 3, so we got our two answers. Oh, wait a minute. We have to check to make sure these are going to work. So what we'll do is we're going to plug them into the original equation. That's just a 9, but here, the original one said log of x. Don't look at this one, that's squared. The original problem was log of x. So we can't use the negative one. So we're going to cross that off and say x equals 3 is the only solution. Make sure you check your answers. You can't take log of a negative. If the original problem said squared, that would be okay. But the original problem didn't have that. I made that. All right, let's do another one. Wow, this example has a lot of logs. When there's logs all over the place, it might be a good idea to combine them. So let's go ahead and put these two logs here together. Since they're both base 5, you can combine two logs to make one log with base 5. Now, what am I going to do to those ofs? Since the logs are being added, you're not going to add the ofs. We're going to use rule number 5 that says multiply the ofs. Maybe what I'll do is go ahead and multiply them right away. X squared plus 8x plus 12. Let's finish the equation. Equals to 1. Now this would not be a good time to say this stuff equals 1. You can't just make a log disappear. And there's not logs on both sides. When there's not logs on both sides, you can't just take this stuff out of the of. So how are we going to get x out of the log? Use a log circle. Use a log circle. So let's just put a note here. Log circle when only one side has a log. Okay, use a log circle. Or here I go. 5 to the power of 1 is 5 equals x squared plus 8x plus 12. I'll move everything over to one side, and that gives me minus 5 plus a 7. And I'm really hoping this one factors. Factors of, oh, I think it does factor. X and x make x squared. And how do you make a 7? That's going to be plus 7 plus 1. Okay, so our two answers are negative 7 and negative 1. Are both of those going to work? Wait, just because they're negative, don't just cross them off. We have to put them into the original problem. Is negative 7 going to work here? Well, that's going to make a negative of. Okay, that one is extraneous. I'll just cross it off and write extraneous. Is negative 1 going to be okay? Negative 1 has to get plugged in. Is this of going to be okay? That's going to be log of a 5. That's okay. And negative 1 here, that makes this of positive 1. Okay, that one's definitely going to work. Okay, don't just cross off the negative answers. You have to see if it's going to go in okay to the equation. Okay, let's do another one. Wow, there's a lot of natural logs here. So I think what I'll do is combine these two. Can you combine two natural logs? Absolutely. I'll make one natural log. And what am I going to do to those ofs when it's being added? Multiply them? Okay, so that makes x squared minus 4x. All right, what do I have on the right? I have another natural log. Okay, so we have two natural logs here. So what I'll do, let's see, is this a good time for a log circle? No, because you have two logs. The same kind of log, and they're equal, and the bases are equal. This would be a good time to say that the of on the left equals the of on the right. That would be a good time to say that the ofs are equal. All right, let's go ahead and solve this quadratic. If I minus x, that's going to make negative 5x. Minus 6 equals 0. Does this one factor? Ooh, I think it does. X and x, don't forget your 0. The way that you make a negative 6 would be negative 6 positive 1. So I got two answers. I got a 6 and a negative 1. Are both of those going to work? Does 6 make any of these ofs negative? Oh, 6 is good. How about negative 1? The original problem had log of just a regular x. That is not going to work. Sometimes the positive ones get crossed off, sometimes the negative ones, sometimes both, sometimes none. You just have to check every problem with the original logs. Okay, so we solved that one. Let's do some more solving. We're going to algebraically solve for x. Now, these are not log equations. So we don't need to be careful about checking the answers to see if they're extraneous. There's no logs here. This is an exponent. But x is in the power. So how do I get x out of a power? You can't divide by it. Oh, I know. Switch to log form. What's the base going to be? The base of the log is the same as the base here, 2. Let's do a little log circle. 2 to the power of x equals 5. Oh, there you go. You've solved this. If you do a quick log circle, you're going to see that that checks. This is exact. Some people are curious and they type this in their calculator to see what the decimals will be. You'll have to do change of base, of course, but then you'll have to chop off part of the answer. This is exact. So we'll leave it like that. X equals. To solve for x means get x alone. That's what it means, get x alone. Since we got it alone, we've solved it. Okay, let's get x alone over here. Is there anything I can do before I start thinking about logs? Well, yeah, you could divide by 8. So you try to do just basic algebra, some little baby math as much as you can until you get stuck. Okay, so we have the fraction 5/8. Any more baby algebra? No. X is stuck in the exponent. It's a good time now to switch to log. What's the base going to be? 3. What's the of going to be? 5/8 equals to x. You've just solved the equation. Now you don't have to worry about is it extraneous or not because this original problem was an exponent. Okay, so that's a review of some solving. We're going to evaluate this log here for a couple of values. Okay, evaluate means plug in the number and calculate and find the value. Evaluate means find the value. Okay, let's find the value. The first input is going to be 1. Okay, so if I plug in a 1, log base 8 of 1. Oh, that looks like a rule. Go back and look at your rules, particularly rule number 2, and tell me what log any base of a 1 is going to make. That's right, it's going to make 0. So let's see, that makes a point, doesn't it? That makes the point 1, 0. All right, now they want us to plug in an 8. So now I'm going to do log y equals base 8 of 8. Hey, when the base is the same as the of, what does that come out to be? Just a 1. So now we found the point 8, 1. All right, here are the two values. We found some points. What this example was trying to teach you was a couple of things. Okay, when you have a log equation here, there's two numbers I want you to plug in. Always plug in number 1. A number same as the base. Okay, and the second number I want you to plug in is 1. Plug in 1. Okay, that's going to help you with this next example here. We have to find the x-intercept and another easy point. An x-intercept is when you have the y value as 0. How am I going to make a 0? If you plug in 1, you'll get a 0. Do you need to see that? Log base 7 of 1, that makes a 0. Always plug in 1. The other number I want you to plug in is the same as the base. I want you to plug in the number 7. What's log base 7 of 7? Well, that just makes 1. There we go. We found 2 points. This is preparing you for graphing logs. Well, let's do it again. What number do I always want you to plug in? 1. What's natural log of 1? Well, that's just a 0. And then the other number I want you to plug in is same as the base, but I don't see a base. Hey, what's the natural log base number? E. Natural log base E of E is going to make 1. For people that want to see the work here, natural log of 1 makes a 0 because that's rule number 1. And then natural log base E of E using rule number 2 makes a 1. Okay, we'll do it one more time. There's 2 numbers I want you to plug in. The first one is 1, and the second one is, that's right, 1/4, same as the base. What's natural log of 1 always going to make? 0. Log base 1/4 of a 4th makes 1. Okay. There's some rules here, and I want you to study these rules. Some of these are true and some of them are false. So carefully look back at your notes and decide which ones are trying to trick you, which ones are true. Some of these are common mistakes. I want you to bring all your true-false answers with you to class tomorrow. And on this next page are some problems for you to try. So this is where the video is going to end. You are going to continue trying all these, and I want you to bring these answers, the solutions to these log equations, with you tomorrow to class. The video is ending, but your notes must be finished. Good luck!